Hello, in this video we're going to talk about an important but simple concept in rocket engineering and rocket science, and that is mass ratios. So you want to get your rocket in the air. What is holding your rocket back? And that is a lot of times mass. You have the mass of a rocket can be broken down into, you could say, three different segments. You have the payload mass. So that can be people, that can be scientific instruments, that can be equipment. Then you have the mass of the propellant, and then the mass of the structure. So a certain combination of these will allow you to get your rocket as high in the air as possible. Obviously, you want to minimize payload mass, increase propellant mass, and minimize the structure mass. So we're looking at a couple mass ratios to kind of like normalize the masses of each component of the rocket to kind of get a gauge on how well a rocket will perform. So first, we can think of the empty mass of the rocket to be equal to the mass of the payload plus the mass of the structure. So that is the mass of the rocket with no propellant. So we could say our full mass equals mf. Empty mass, we'll call that equal to me. So mass full equals the mass of the payload plus mass of the propellant plus mass of the structure. We have a ratio called the propellant mass ratio. And that can be symbolized with mr. Sometimes I've just seen it as just r. And that equals the mass full divided by mass empty, which can also equal to 1 plus mass of the propellant divided by the empty mass. And then we have the payload mass ratio, which equal to lambda, which equals md, mass of the payload, divided by the full mass minus the mass of the propellant, which can also be equal to mass of the payload divided by the mass of the propellant. That should be propellant. Mass of the propellant plus the mass of the structure. So you want to maximize this. Yeah, you want the payload to be a large ratio. Maximize that as much as possible. Then you have the structural coefficient, which is epsilon. And that equals to the mass of the structure divided by the mass of the propellant plus the mass of the structure. And then our mass ratio can also be wrote as 1 plus lambda divided by epsilon plus lambda. So pretty simple concepts. Those are just some of the rocket mass ratios.